Hola, my friends. Here we are with problem number 4 on the investigation about quadratic functions. And you were asked to find the equations for these 3 different graphs. So I just want to go ahead and point out to you, if I can try to sketch this. The one that I just highlighted here. Mercy. Struggling. The struggle is real. Okay. Hashtag parabola problems. So this is the sketch of the original. Let me just group these guys together because I'm going to move them here in a minute. So this is the original equation, and the original equation, or the parent function for quadratics, is y equals x squared. Okay, so it doesn't appear that these other ones have been made thinner, right? They're not made thinner in any way, and they haven't been widened out in any way. So what we're just looking at here is simply a slide or translation, and they went from having crossed the y-axis at 0, 0 to now crossing the y-axis at the coordinate point 0, positive 3. So all we've done there is we've just taken x squared and we moved it up 3. Okay, so that's this graph right here. And then, as I told you, this pink one is the y equals x squared. And the one underneath this has had a shift down of 3, so that's y equals x squared minus 3. And then the last one is also a shift down, so it's x squared minus 5. So you can see how the value that's after this x squared button represents a shift up or down. Alright, so I'm going to move this guy over. Look how awesome that thing's drawn. So this represents our original, y equals x squared. Now we've got to take a look at how these are changed. So first of all, we've taken this guy and we've, let's see, flipped him over. So taken the original, and he's been flipped over the x-axis, and then he's been moved up 1, 2, 3 places. And this other guy's been moved up 3, 4, 5 places. So your first equation, we're calling these g of x because they're different graphs, x squared plus 5. I'm sorry, negative x squared plus 5. And that negative, some of you all were doing a good job today of figuring out what this negative meant. But a negative means it flips over the x-axis, and then this plus 5 is how it's shifted up. So in the same way, the negative x squared flips it, and plus 3 is the one that shifted this guy 1, 2, 3 places. Okay, so I'm going to go ahead and readjust this guy back to the very well-drawn original point. And how have these other guys changed? Well, this guy's just moved down 1, 2, 3 places, so that would be x squared minus 3. And then what do we do for the other one? We shifted down 2 more to make it x squared minus 5. So as you can see, x squared minus 5 here, and x squared minus 5 here, same equation, and they should also look the same, right? Alright, problem number C. Look how much different problem C is. If this is my original, alright, that's where the original sloppy picture sits. And these guys are definitely wider, as well as being flipped over the x-axis. Okay, so how have these things adjusted? So our first one we're going to look at here will just be the closest to my original, and it appears as though this one has really just been shifted down 3. The way that you can check and see if these have been widened out or not is by checking out the table values. So if you say to yourself, you know, that really looks like it's just moved down 3, then you could try out the equation x squared minus 3 and go to your table and see if the point 0, negative 3 is on there. This looks like it goes through, it's hard to see from where the actual point is, Try to find one that's kind of in the crosshairs. Looks like maybe 4, positive 4 might be on that. But you can go and check on your graph. And it does turn out to be that the first one is x squared minus 3. Okay, so we're looking at how it adjusted from the original one. And then it's just sort of a matter of playing around with numbers. You know that, as we discussed today, fractions or decimals are what widen these guys out. So playing around with some of those possibilities finds our answer to be 1/7 x squared. And that's this guy right here. Boom, boom, boom. Widen it right out. Taking all the values for x, it's squaring them, and then it's multiplying them by 1/7. Alright. It appears as though, I'm going to flip this guy around, because it does look like these two here on these rainbow looking ones on the bottom have been reflected. So if I flip the original, which turns it into negative x squared, and I move it up 3 places, that looks like it, if I had drawn this pretty, that looks like it hits it just right. So this one would be negative x squared plus 3. See again how it used to look like this. So the negative reflects it or flips it around. And I keep moving it down because it's got to have the same y-intercept. It's got to have the same vertex. And then moving it up 3 is where that plus 3 is. And since this one here, let me get this guy out of the way. Oh, excuse me. Since this guy right here and this guy right here sort of seem to be reflections of each other. Alright, looks to be the same width. I would also try on my calculator to see, well, it appears to have the same horizontal stretch here. This negative is what flips it over the x-axis. And then it's been stretched out wide. It's been flipped, it's been stretched out wide, and then it's been moved up 3. So it looks like this one here should have said minus 3. This 1/7 x squared should have said also minus 3 on it, and that would have been those. So there's problem number 4. I hope this helped you out.